So here, what we are, so we have seen in the previous class recursions. And after that, I said about lambda, lambda functions. We have seen how to work with the lambda functions. Okay. And after that, so I said where these lambdas are used. I'm talking about function tools dot reduce. See, reduce is a function. So this is reducing a collection of values to one value. So how to reduce a collection of values to one value? So that you define it as one function. Okay, how to reduce collection of values to one value? So that you write it as one function here, right? So function is there, iterable, and one more is what here? Initializer. So apply function of two arguments cumulatively to the items of iterable from left to right. So as to reduce the iterable to how many values? Single value. So it will reduce to single value. That is done by using a function called which one? Reduce. For example, so reducing to one value, right? Suppose now you have to write a function with two arguments. So I take one list with some values. So assume that these are the values in the list. I want to reduce this 5 values to one value. I want to reduce this 5 values to what? One value. But how to reduce? Which function you want to apply to reduce? Okay. So I try to import here. So import, there is one function module called function tools. And after importing function tools, okay, what you are doing is you are reducing to one value. Suppose value equal to, so function tools dot reduce. So followed by which function you want to apply. Suppose I want to reduce to one value by applying one function called sum. What is this function I'm applying here? Sum. So this function will take how many values here? Two values. And then return this value. See here, apply function of two arguments cumulatively to the items of iterable from left to right. So there is a cumulative value and there is accumulated value. So x is accumulated value and y is what accumulated here. So x comma y, x plus y, comma, what I'm doing, I'm just applying which one? List 1. So here it is reduced to one value. What is this value? 150. Because which value applied here? Adding. So what is the x value? 10. And what is the y value? 20. Then x plus y value is what? 30. Then what is x value? 30. And what is y value? 30. And 30 plus 30 is what? 60. Then what is x value? 60. And what is y value? 40. Like that. Okay. So you can also define the initial value. So which function you want to apply, you define that as one function tools dot. Okay, you are writing like this, value equal to function tools dot reduce and you are using lambda. Yes. Okay, now this will receive how many values here? Two values. So return x value if x is greater than y, else return which value? Y value. Now this lambda is finding maximum. Now this will return which value? Maximum value. This return which value? Maximum value here. If I'm saying print value, so what is the value written? 50. So this will return which value? Maximum value. Suppose what is x value? 10. What is y value? 20. So is it 10 is greater than 20? No. So it returns which value? Y value. So y is written into what? X. Y is written into what? X. Then next what is the x value? Y value? 30. So is it 20 is greater than 30? No. So then it will return y value which is written into x, that is 30. Is it 30 is greater than 40? No. So it will return the y value into what? X. So here I apply the function called maximum. So which function you want to apply? See, you have which function you want to apply? Which function you want to apply to reduce this collection of values into how many values? One value. X, if x is less than y, else you are writing y. So this is on list 1. So what is the value written here? Yes, the value written is what here? 10. Okay, so you are applying one function. So which function you want to apply to reduce a value to one value? But that function, I'm representing it as what? Lambda. That function, I'm representing it as a lambda function, right? See, this is where lambdas are used as which functions? Higher order functions. Higher order means the function which receive input as another function. But you are representing that function as which one? Lambda. So function argument. It is represented as what here? Function argument here, right? So next, yes. Yeah, this is how you work with the lambda functions, right? Next we'll see another chapter which is called as modules and which one? Packages. So modules and packages here. How to work with this? So there is one thing is there like monkey patching. We'll see that in object oriented or in modules also we can see that. But we'll see what is exactly this modules and what is that? Packages. So generally, yes. So generally a project, you never develop application by writing everything inside one program. Okay. You never develop a software or you never develop an application by writing everything inside what? One program. You don't write everything in one program. You divide the functionality of your program, application, into number of programs. That is where you'll say a software is a collection of, actually a software is a collection of which one? Programs. Is it software is one program or collection of programs? Collection. Software is not one program. It is a collection of programs. For example, you are developing application for a bank. So this is which application? Banking application is there. Okay, this is banking application. And you are trying to divide. So this banking application is having so many operations. This banking application is having so many operations. According to the operations, you are trying to divide this into a number of programs. For example, assume that there is a program called accounts. There is a program called which one? Accounts. In accounts program, there is functions belongs to accounts, like how to open the account, okay, how to update the account, how to delete the account. Okay, these functions are there in which program? Accounts program. Accounts program is having all the functions belongs to what? Accounts. So there is one more program called which one? Transactions. So transaction is one program contain transactions like which one? Deposit. The functions like deposit. So the functions like which one? Withdraw. The functions like what? Transfer funds. So all the transaction related functionality in which program? Transaction programs. So there is another program called which one? Reports. Reports is like check balance, check balance. Okay, so this is yearly report, monthly report. Okay, so these are the functions belongs to which one here? Reports, like printing the passbook, printing the passbook. All these functions belongs to which one? Reports. But is it all these functions are put in one program? No. So it is divided into how many programs? Three programs. So that you can easily identify which function is where. And not only that, more than one person can work on this project. For example, one person will develop which program? Accounts program. One person will develop which program? Transactions program. One person will develop which program? Reports program. So how many people are working on this application? Three people. It means you are not writing everything inside one program. So you are trying to divide your application logic into a number of programs. And then you use the content of one program inside what? Another program. So use the content of one program inside another. It means you are dividing your application logic into a number of programs. And in Python, each program is called as which one? Module. I said in the beginning, in Python, each program is called as one module. So this is one module, this is one module, and this is one module. Each program is called as one module. So accounts is one module, transaction is one module, reports is what here? Another module. You are divide because program is nothing but what here? Module only. Every Python program is called as one module. So Python supports which programming? Modular programming. Means where you are dividing your application logic into number of programs. In the previous case, you divide application logic into number of functions. So one program is divided into what? Number of functions. But now you are dividing your application into what? Number of programs. You are not writing in one program. You are dividing into what? Your number of programs. And then you'll be using the content of one program inside another. So what is a module and what is a advantage of using modular programming? So what is module in Python? So what is module? What is module in Python here is, so every Python program is called which one? Module. Every Python program is a module. Okay. Every Python program is called as one module. Okay. So what is a module? Is a Python program. Every Python program is called as one module. So generally a module is saved with the extension dot. Okay, a module is saved with the extension dot py. Okay, a module is saved with the extension. A module is saved with the extension .py. A module is saved with extension what here .py. It's nothing but Python program, right? So what is a module? A module is a collection of what? Variables. A module is a collection of variables, comma which one? Functions, and which one? Classes. Now classes means next after this you learn how to write classes. But a module is a collection of what here? Variables. A module is a collection of which one? Functions. And a module is a collection of which one? Classes. Okay. And these modules, okay. So modules are, okay, modules are what, how many types here? Two types. One is called as a predefined modules. One is called as a predefined modules. The other one is called as a user defined modules. How many types of modules are there? Two types are there. One is predefined modules, and one more is which modules? User defined modules. Predefined modules means predefined programs, and these are nothing but libraries. These are nothing but what here? Libraries. So existing modules are called predefined modules. Existing modules are called predefined modules. So these are also called which one? Libraries. These are also called libraries. Example is, now you find a library called which one? Math. You find a library called which one? Sys. You find a library called, now just now we use, what is that function? Tools. You find a library called or module called copy. So there is a module called date time. There is a module called which one? Calendar. So, okay, all these are which modules? Predefined. So the modules developed by whom? Programmer are called which modules? User defined modules. The modules developed by programmer are called user defined modules. Okay. These are, you can say, application specific modules. Application specific modules are called which modules? User defined modules. Example is, when you develop a project, you may develop modules like accounts.py, okay, transactions.py, reports dot, okay, what is this here? Py. So every Python program is what here? Modular. So modules, what is the advantage of dividing into modules? What is the advantage? Advantage of, what is the advantage of dividing into modules? What is the advantage of dividing into modules? Okay, first one is easy to understand. Easy to understand which function is where. You can easily understand. Okay, suppose if you see here, all mathematical functions are in which module? Math module. All system related functions are in which module? Sys module. Date time related functions in which module? Date time module. Calendar related functions are in which module? Calendar module. So here all the modules, I mean, you can easily identify which function is where, right? In the same way, all accounting functions will be there in which module? Accounts.py. Like transaction related functions are in which module? Transaction.py, like that. So You can easily identify which function is where, okay, by just seeing which one here module, right? So the modules developed by programmer are called user defined. Now easy to understand and easy to maintain, the code, easy to maintain, okay, easy to maintain what here code, okay. So I can do the changes in accounts functionality without any changes in what transactions as well as reports. I can do the changes in reports functionality without doing changes in transactions and what accounts. So easy to maintain the code and reusability. Reusability means I can use the content of one module inside what another module either one time or more than one time. Reusability of the code between the programs, and next one is modularity. So that is nothing but dividing. Modularity means dividing your application logic into a number of programs. Dividing your application logic into number of programs. Okay, dividing your application logic into a number of programs. Okay, this is your application. Don't write all the functions in one. So you don't write in one, but you divide into number of programs. So these are number of programs, and each program is called one module, and this is called as accounts.py, and this is called as a transactions.py, and this is called as a reports dot which one py. So this is one module, and this is one module, and this is one module. So here you are writing all the functions. What is this? Open account. So there is a function called open account. There is a function called update account. Okay. So there is a function called delete. Delete what is that account? Now in this you may find the functions like there is a function called which one? Deposit. So there is a function called deposit. There is a function called which one? Withdraw. So there is a function called transfer. Okay, transfer funds. Okay, so all these are the functions, right? So there is a module called reports where there is what here passbook printing. Okay, so there is a function called passbook printing. There is a function called which one? Check balance, like this. Means your application logic you divided into how many programs? 3 programs, and each program is having some set of functions. Okay, now so all these functions are written in one program? No, all these functions are not written in one program, but divided into how many programs? 3 programs. Okay, so that is called as a modularity. That is called as which one? Modularity, right? Right. So, but every module is nothing but a Python program only. Module is nothing but which one? Python program, which is saved with the extension what dot py. So there is a predefined modules and there is a user defined modules. Predefined modules means existing modules are called predefined modules. And these are also called which one? Libraries. But the application specific modules are called user defined modules. Okay, are the modules developed by Python programmer are called which modules? User defined modules like accounts.py, transaction.py, reports.py. All these are which modules? User defined modules like this. Now you have to understand this. Now this is a banking application which is divided into how many modules? Like 3 modules. Accounts.py, transaction.py, and one more is reports.py. So writing a module is nothing but creating one program only. Okay, now writing a module is nothing but writing one program. So till now we write so many programs, but all programs what we write till now, all those are what? Modules only. So don't think that module means something else. Every program is one module. Okay, but these modules are again two types. User defined modules are two types again. One is executable module and second one is reusable module. So this user defined module or application specific modules are again two types. One is executable module and one more is reusable module. What is executable module? Means executable program. A module or a program contain which statements? Executable statements. Executable statements is called a executable module or executable program. It means it is a module which you can run. Now till now we write all the programs and all these programs can you run or not? Yes. For example, I'll write one program like this, new file. I'll write one program saying that print, okay, I'll write some function one. So this is function one, right? Then I'll write here function two. Okay, then I'll write function two here. Okay, then I save this program. Then I save this program here. Okay, so program name, you can give any name, but I'm just writing the name as which one? Module 1. What is the name of the program? Module 1. Any program you can give, right? Because program name is user defined or predefined, user defined. Now can I run this program? Can I run this program? If I run this program, is it any output here? No. Because is it this program is having any executable statements? No. What you write inside this program? Only functions. What is there in this program? Only function definitions. We write a functions, but are we called these functions? We write a functions, but are you called these functions? No. If you don't call the functions, will it functions executed? No. It means is it any executable statements in the program? No. There's no executable statements within the program, right? Suppose I'm calling function 1 and function 2. So this is called as which module now? Executable module, because it is having which statements here? Executable statements. If I run this, will I get any output or not? Yes. But if I don't write this, this is executable module? No. This is called as which module? Reusable module. Means this module functions I can use inside what? Another module. Like suppose math is there. Math is called which module? Reusable module. We import math module and we call which one? Functions. We import calendar module and call the functions of what? Calendar. We import some function tools module and call the functions of which one? Function tools. So those are called which modules? Reusable modules, which doesn't have which statements? Executable statements, but that module is having only function definitions. That modules are having only function definitions, but doesn't have any calling of which one? Functions, right? So the module which doesn't have the module, a module or program contain executable statement is called executable module or executable program. A module or program, okay, which doesn't have what? Executable statements. Executable statements is called which module? reusable module. So reusable means you cannot execute this program, but you can import this program into what? Another program and call the functions. You can import this program into another program and call the functions. Okay, this module can be imported. This module can be imported inside another program and invoke which one? Functions. This module can be imported inside another program and invoke functions. This module can be imported in another program and invoke the functions. This module can be imported inside another program and invoke the functions here, right? Please just try to understand what is a executable module and what is a reusable module. A modular program which doesn't have any executable statements is called which module? Reusable module. And this module can be imported inside what? Another program and invoke which one? Functions. Okay. For example, yes. For example, here I write one module. What is the name of the module? Module 1. And in this module, how many functions are there? 2 functions. But is it this program or is it this module is executable or reusable? Reusable. Because this module doesn't have which statements? Executable statements. This module doesn't have any executable statements. Okay. You cannot run this program. If you run this program, you don't get any output. If you run this program, you don't get any output. Then why you develop this program? Why you develop this program? To use inside what? Another program. Why you develop this program? To use inside another program. To use these functions inside another program, I develop this. So this can be used either in one program or more than one program. Then how to use the content of one program inside another program? You can use the content of one program inside another program using which keyword? Import keyword. Import keyword or import, what is this? Statement. Import keyword or import statement. Okay. Suppose I develop one module. I develop one module here. Suppose the name of the module is module 1 dot name of the module is module 1 dot py. What is the name of the module? Module 1 dot py. And inside this module, you have some functions, right? So there is a function 1. Okay, there is a function 1 and there is what here? Function 2. So there is a function 1. Okay, this is function 1. Okay, this is function 1. And this one is called as what now? Function 2. Now I want to use these functions inside which one? Another modules. Other modules. Okay. Okay, assume that there is one more program called module2.py and there is one more program called module3.py. So there is a module2.py and there is a module3.py. So I want to use the content of module 1 and the content of module 1 into module 2 and in module 3. How can I call this function 1, function 2 of module 1 into module 2? How can I call this function 1, function 2 of module 1 into module 3? By using one statement. What is that statement? Import. What you are importing here? Module 1. And then you are calling module 1 dot Module 1 dot. Dot means accessing. From module 1, you are accessing which function? Function 1. You are calling function 1. So module 1 dot, you are calling which function? Function 2. In the same way in module 3, I'll just write here import module 1. Okay, then I'll say module 1 dot, module 1 dot. I want to invoke the function 1. So I just write here module 1 dot, function 1. Module 1 dot function 1. Again, I said module 1 dot, module 1 dot, which one? Function. So I call the function 1 of module 1. I call the function 2 of which one? Module 1. But how I called? By using one statement called which one? Import. So import using the content of one module inside another module. So import statement is used. Okay, import statement is used to import or use the content of one module inside another, inside which one? Another module. Import statement is used to import or use the content of one module inside another module. So here importing is not including. Importing is not including the content of, not including. Importing is not including content of module, but importing is, okay, not including the content of module. If you are saying import, is it this module content is imported here? No. This is not inserted here. Importing is not including content of module. Importing, okay, importing is, okay, so import statement or import keyword, import, okay, import the identifiers, import the identifiers exist, or importing is, generally you'll say importing is creating, okay, importing is creating what here? Namespace. Importing is creating what here? Namespace. So what is the meaning of namespace here? For example, when you say import module 1, okay, import module 1. So within module 2, your Python virtual machine create a namespace. Okay, there is one dictionary here. So what is this dictionary here? Global dictionary will be there. Okay, so in this, it will try to import, what it will try to import? It is trying to import one name. What is the name it is imported? Module 1. From module 1, it is trying to import how many identifiers? Function 1 and function 2. So what is imported here? What it is imported? Module 1 is imported. From module 1, it is imported which one? Function 1. From module 1, it is imported which one? Function 2, right? But what is imported here? Names. What is imported here? What is imported here? Names are imported. Which name is imported? Module name. Which name is imported? Function name. Which name is imported? Function 2. But when you say module 1 dot function 1, it look for this module 1 into which namespace? Module 1 namespace. Module 1 namespace, where it look for the function 1. And calling of this function 1 is done at which one? Runtime. Calling of this function 1 is done at which time? Runtime. It means function 1 is included here, or function name is included here. Function name is included, but invoking of the function is done at what? Runtime. So importing is not including. Importing is not including. Importing is creating what here? Namespace. So what import is doing? It is importing only names, but it is not importing which one? Content. But importing include only names. Okay, namespace means, okay, importing is creating a namespace. Okay, import keyword include. Okay, include or import Include or import which one? Names. But it doesn't import which one? It doesn't import which one? Content. If it is import the content, see, if it is included that program here, the size of this program increase. For example, if this program is having 100 functions, if this program is having 100 functions, if you import all the functions here, if it is include all the functions here, the size of the program will become what? 100 functions. The size of this program increases or not? Yes. Because of that, it doesn't include this program. Importing is not including here. Importing is creating only which one? Namespace. Means it just import which one? Names. But which names are imported? Only the names what you are using it. Only the names what you are using. Now, how many names are used? Two names. What is that? Function 1 and function 2. So that it will be invoked during which one? Runtime. So module 1. Where is this module 1 along with the path? So importing is not including the program. Importing is including the names of that module. Importing is including the names of that module. Okay. But there are different syntaxes. There are different syntaxes of this import keyword. Okay. Now syntax of which keyword? Import keyword. So what is the syntax of this import keyword? So there are number of syntaxes out there. Import, what name? Module name. And second one is import, okay, module name as which name? Alias name. And third one is from module name. From module name, import star. Fourth one is from module name. Okay, import identifiers. Okay, identifiers. Identifier means that can be variable name. Identifier means that can be variable name or function name. From module name, import from module name, import identifier as what name? Alias name. Import identifier as what name? Alias name. Okay, so these are 5 syntaxes of which one? Import statement. So import module name as what name? Alias name. From module name, import what is that? Star. And from module name, import identifier, comma, identifier. From module name, import identifier as what name? Alias name, right? So first syntax is import. What is this here? Module name. So this import the entire module. Okay, this syntax import entire which one? Module. Okay, the syntax import the entire module means you can use the content of this module, any function or any variable available in this module, any function or any variable available in this module. So this syntax import the entire module. Entire module means you can able to use any function or any variable of this module, right? Yes. Now using one import statement, you can import only one module. Suppose, assume that. Now this is module 1. What is this now? Module 1.py and this is module 2.py. So two modules are there here. One is a module 1 and one more is a module 2. So what I write in module 1? Some functions. Okay, na? So there is a function 1, function 2, and there is another function called function 3, and one more function called function 4. So print function 4. Now this module 1 having how many functions? 4 functions are there. In module 1, how many functions are there? 4 functions. I want to use these functions in which one? Module 2. I want to use the content of module 1 into what? Module 2. Then how can I use the content of module 1 into module 2? Then I use which statement now? Import. Which module you want to import? Module 1. Which module you want to import? Module 1. Which module is imported? Module 1 is imported into which one? Module 2. You just access this global namespace. How can you get the global namespace? By using a function called global, and just print this global namespace. You'll be knowing it. So what is the name of the function? Globals. What is the name of the function? Globals. You can see which one is imported. Name is imported. See here. What is the name here? Module 1. Okay, where is this module 1 is available? See, name is imported along with which one? Path. Okay, now, so from where, see, this is a name, and this name is bind with which one? File. What is the name of the module? Module 1. What is the name of the file? Module 1.py. So whenever I say module 1 dot, then from where it is loading this function? Module 1.py. So name is included, module is included, name is included along with which one? Path. Name is included along with which one? Path, right? Name is included along with the path. So this is what exactly the meaning of it, right? Yes. After this, I'm saying module 1 dot function 1. And then I said module 1 dot function 2. Now you just access again globals. Again you access globals now. Suppose some G equal to globals. And if I try to print a GA, so what will happen? Now you can see, okay, so this is a globals. Even there is a variable called which one? Global. But which one is called here module 1? So after this, now there is a message. What is the name of this here? Function 1 as well as what? Function 2. But from where it is calling this function 1 and function 2? From where it is calling this function 1 and function 2? This function 1 and function 2 is there. But what is G here? Is it a dictionary or not? Globals is one dictionary or not? Yes. Just to print this dictionary and see what is their content inside this. So for value in some globals dictionary and print this G here. Okay. Yes. So why this changed? Because there is a variable called which one? Value. So there is a variable called which one? Value is there. So actually G is what here? Dictionary. So what is a G here? Dictionary here. G dot, what I said here, keys. And then you can print, what you can print here? Keys. Okay, now what are the keys here? So which one is now dictionary of keys? But what is there in this? Only one name is there. What is the name of this here? Module 1. But see, but what I want to tell you is whenever, what is the meaning of this is whenever you are saying module 1, where it is referring to the module 1? So module 1 is referring to which program? Module 1.py. So when you say module 1 dot function 1, it is calling the function from which file? Module 1.py. But is it function is included here? See here, is it function is included here? No, function is not included. Function is not included, but it is included as a part of which one? Module. How you are accessing this content of this module with what name? Module name. So which one is imported? Module name is imported or module is imported? Module name is imported, and that module name is bind with which one? File. Okay.